Right, so you confirm you can see my slide, so I may continue. Right, thank you. All right, so today we're going to look at the platform management side and the usage of Fusion Sphere, and we're going to look at how do you actually manage using that platform. So essentially today we will look at the client side of how you would use Fusion Compute as a cloud operating system, and also to see how it virtualizes the hardware resources. We've covered the aspects of what it can do. So we'll look at how it virtualizes the hardware resources, how it centrally manages virtual service and user resources, and then also to show you how the compute, the storage, and the network virtualization features are set up with regards to you that needs to manage the platform using Fusion Compute. So it basically covers the whole part of talking about virtualization and how Fusion basically operates, which we mean, remember what we said last week, it actually reduces your OPEX, your operational expenditure, because it does many things altogether. So it takes away that burden of a high TCO, total cost of ownership, right? So the main thing of today's objectives will be to understand Fusion Compute. So why I always highlight this, the outcomes objectives, is that if you remember your Bloom's, I don't know if you still remember Bloom's taxonomy. So it depends on the level of what we want you to understand. So if we say understand, it means we just want you to understand. We don't want you to, at this stage, evaluate or analyze, those high doing words. It's more just about understanding Fusion Compute and how virtualization features work, also understanding the storage side, also understanding the network virtualization features. So those are the three things that we want you to understand from this, and then also to familiarize yourself with Fusion Compute, the system itself, and how you manage the resources. Right. So that is mainly what covers the objectives with regards to if you like. I just wanted to show you this. Maybe I should just show you that so that you really understand at which level. If you didn't look at a learner guide or something. So when we look at your Bloom's, I think it's Bloom's taxonomy. And so when you look at the level of where you being evaluated, and that's normally how your exams will be set up in a way. So when you look at Bloom's taxonomy, we are at the understand part of the triangle. So here we want you to explain the concepts. We want you to classify, describe, discuss, explain, identify. Those kind of keywords is what we expect from you, right? We're not at the create stage or the evaluate stage or the analyze stage. We had to understand it. So just remember that the way questions are going to be phrased to you when you do the exams, that you need to, classify those keywords based on the objectives, right? So I just thought I'd show you that part. Okay, so basically, moving on, we will look at the concepts that relate to compute virtualization, and then also we'll look at the list as we go through. So regarding compute virtualization, we previously said that, Fusion Compute, is this whole virtualization platform that we use, and it obviously has to give us these resources that we need to use for our cluster. It also needs to give us resources that we need to use for our network, and also resources that we need to use for our storage. And so Fusion Compute, again, that whole system as a whole, looks at your physical CPUs, your physical memory, and all of that, and basically create this resource pool, so that we have the setup like this. So you can see here you have a physical server. So there's server 1, server 2, server 3, and you can see that there's the layer that gets created. And that virtualization layer is you can call it an API, but it's basically just the interface between your hardware and the software, right? And so that's where we create a storage pool. Like here you have a CPU resource pool, here you have a memory resource pool, And that pool then allows you to take from that pool and allocate resources based on what's needed. That should be an arrow. Based on what's needed for each virtual machine, right? So this is mainly how the whole virtualization works. So depending on what you run on that server, you could then, have the resource pool, all that servers all working together as one. And that is ideally what you want to see. So you have a physical PC server, sorry, you have your virtualization layer, you have the storage computing pool, a resource pool, and then you have, your virtual memory that's now being available to use for your operating system. And so these operating systems could be, you can look at it as one, two, three, four, five, six, seven different operating systems you run on 3 servers, right? Now, if you had to do it just one operating system on a server, obviously it's going to be isolated because it won't be able to handle any failures. And so that is mainly what we want to do with regards to Fusion Compute. So number one, it hosts the physical server and the layer. That's only after you installed Fusion Compute, the host OS, on the server. And then also after that, it automatically then virtualizes the resources. So just to keep note that your virtual CPU and your memory resources used by the VM must be provided by the same host, right? Let's just note it needs to be provided by the same host. If that host fails, then the system will automatically assign it to another host to provide those compute resources. So you basically have to know that whatever resources available for you for that house, it won't exceed the availability. So if you have, let's say, 4 CPUs here and 4 here, um, right, for this VM, then in total this house would have 8 CPUs, and so it won't go over that capacity. It's only there if something happens to this machine. If this machine goes down, then it will move it across to that machine that's there, right? So that's kind of the whole compute virtualization part of how Fusion Compute works. So when we look at, the key things, you have your CPU virtualization that we just explained now, but we can also see that, Fusion Compute uses KVM, and that was the technology we mentioned, the kernel-based virtual machine, for the compute virtualization. That's for the CPU. And then the KVM is a CPU-based hardware-assisted virtualization. So here we come back to our topic we covered way in the beginning, where we spoke about virtualization basics, and where we said that you have this -1 kind of ring. We call the ring where you are actually behind your the zero ring, which is on top of that normally, which is root. So that is basically why we have the hardware assisted virtualization. And so that requires the CPU to support the virtualization function. And that's why it's KVM. Okay. So when we look at the memory virtualization again, we can see that it's the actual physical memory of that machine that's being managed by the central, should be node, not mode really, but you could say it's mode and node. And obviously that is packed into multiple virtual memories for the VM. So that is the memory virtualization, which just works, as it needs to be allocated. And then your input output IO is more your different middleware layers. So it depends on what needs to be accessed. Certain variables or resources, keyboard, mouse, if this needed, your virtual disk, your GPU, USB, whatever you need virtually, that would normally be considered there. Right, so when we look at, the three again, just to refresh, remember we said that full virtualization is we use the virtual machine monitor to virtualize the CPU, memory, and the device input, output, and then you have a guest OS and the computer hardware that doesn't need to be modified. That was the full virtualization. And then the para virtualization is we have the virtual machine monitor that implements the CPU and the memory virtualization, and then there's also guest OS to implement the input output. So he sits obviously in the middle, but the guest OS always needs to be modified so it can work with the virtual machine monitor. So there is this interaction that still needs to be modified because it's too high on the compute side. And when we look at a hardware-assisted virtualization, we now have a full virtualization with the hardware, mainly processors. And so the guest always does not need to be modified. And so that compatibility is good. So what we can see from full virtualization is that it has a good compatibility, but you have that extra overhead to the processor. The processor have to go through different steps, and that makes it obviously, it basically gradually eliminate, the difference between the software virtualization and obviously the one we want to have, which is the hardware. So just to recap on that, just to show you basically where this comes from, if you recall, when we spoke about virtualization, um, just go back. You remember this part where we said, where you have the different virtualization modes and it needs to go through all these layers to get to the hardware, like in this case, the CPU. And this is where we spoke about the different types. So I'm just going to go to that slide, this part here. And this is what I'm referring to, where you have your your virtual machine monitor, in this case, your cloud, let's call it Fusion Compute, that has, the direct root mode access, which is, to the hardware, as you can see there. And if you look at your normal virtualization, you have the guest always sitting at ring one. It still needs to connect, to the guest always, and that's the part that you showed earlier. The part that we didn't want to have. But again, it all depends on how the CPU now needs to send these instructions across. So you get, again, this is the best mode of virtualization because you directly attach to the hardware, the CPU that's needed. So you don't have to do any switching between the rings and the permission structure. Right. So that is basically, the whole part. And if you look at the normal one where you don't have any virtualization needed, you can see that your operating system, like let's say you run Windows. Remember when you install Windows, it sees the CPU immediately, right? When you do a normal installation on your laptop or your PC. So there is no virtualization involved, but you can see your OS kernel is directly connected or attached directly to your hardware, like your CPU, your RAM, and your hard disk, right? But when you do virtualization again, you separate that and it creates like this layer here, which still needs access. And so your guest always moves higher and means that it needs like the virtual machine permission to get to that in order to get to the hardware. And you can see here, this is a different setup. Here you have your Fusion Compute in this case that actually has the attached. So it has a similar setup as the no virtualization. However, you can see that it acts as, directly attached to the kernel, which is why it's called KVM. Right. So I thought I'd just bring you back to the virtualization parts we covered, and just so you can see really why we have this talk about hardware assisted virtualization and why it's preferred in a way. And yeah, because you can go for full, but again, there's overhead, and you don't want overhead where the guest always still needs to go to another layer. Right. So again, when you look at the VM resource management, again you can see here basically that you have OpenELA, which remember we said is Linux. It's a Linux OS, and OpenELA is an operating system that sits there, and it obviously manages, your hardware resources, and then obviously allows you to have this virtual resource pool. But again, Fusion Compute then obviously push that particular VM or whatever ISO it's needed, which is OpenELA in this case, and then it uses from the resource pool in order to allocate to OpenELA. Right, so and then obviously on top of OpenELA, which is a Linux OS, it runs a certain application that's needed. And so the application could be maybe a web server, I'm not sure, it could be anything. It could be a web server, it could be something else, right? It could even be Fusion Access, whatever you need, or particular service that's needed. That would be the app there. But again, this is basically how this whole resource management works. So there's this whole thing of VRAM, which obviously stands for virtual RAM, and you have vCPUs, which stands for virtual CPUs. You can add them offline and online, and can be deleted offline, right? So that is basically a way of how you can manage your resources. Also, your CPU and your memory specifications can be adjusted when your VMs are running. So that makes it easier without needing to restart the VMs. Another thing also is, and this is all the benefits, so just keep in mind of all these benefits because it shows you how Fusion Compute stands out amongst others. Remember with VMware or any other virtualization technology, you still have to switch off the VM first before you can do any changes. So this is that hot swappable kind of setup that you can do. You can do it in VMware, but you need to specially configure it so that it can increase resources and decrease resources if needed. Also, it applies to services that require flexible adjustments. So if you need to increase your number of CPUs and your number of VMs, that normally is the setup. So I'm not sure if you guys know that normally when you do registration, you tend to have to increase your load capacity resources so that you can, adjust your server or your applications to handle, concurrent users, right? So let's say, for instance, you need to handle 10,000 or 100,000, concurrent users. So we'll just say this is concurrent users, and you would need that maybe just for a week, right? So 1 week. Then you would basically scale up your resources to what's needed, right? And then when that registration is done, you then scale it down maybe back to 1,000 you concurrent users. And so you would then basically scale it down, and then you might not need all that resources. And so that is the whole thing of the flexible adjustment that's needed for certain resources. Again, this flexibility adjusts the VM configuration based on the site requirements or whatever is needed. Supports scale up to ensure your quality of service, so that's a QoS for each VM, and it integrates the scale out and ensure the cluster quality of service. So that scale up and scale out, that's the availability. So now normally we would see scale up is scaling up, and then you have scaling down, but now you have scaling out and scaling in. So you have this whole part of scaling up the resources, whatever's needed, scaling down, but you can also scale out, which means you can actually increase the VMs if needed, or you can decrease the VMs if needed. And that's mainly why Fusion Compute have that value. So it has a scale up and scale out part. So if a VM is offline, the number of capacity of that can be reduced, so you could get back that resources when that VM is down. um, you know but you can also add or delete network interface cards if you need it. You can mount disks online and offline, and if the VM is offline or online and it uses the virtual storage, you can also expand that capacity by adding existing disk capacity without needing to switch off the VM, right? So in a nutshell, what I'm trying to tell you is that if you have something like, let's open up Fusion Compute again. So this is Windows 10, 11, right? This is a VM. So if I now, this is now running. So if I now wanted to, let's just resume it quickly. Um, and so for instance, if I now want to increase, all right, you guys can see my screen still, right? Because I have this VM now here running. Can you still see Windows 11, the screen? I'm just double checking. Okay, thank you. Right, so if I now want to increase the resources here, so let's say I've got memory and CPU. Now you can see here, it's grayed out. You need to switch the virtual machine off. And what we're saying is that with Fusion Compute, you don't have this problem, right? You don't need to switch it off. You can scale up the memory if you need it, or scaling it down. You can scale up the CPUs and the cores if you need it down, or scale it down. And many of these, variables that you see here, well, this is all for the PC, but let's say the network adapter. You can't add the device because, if I say now, add in your hard drive, you see you have to switch it down. Add a CD-ROM, you need to switch it down. Add a network adapter, you need to switch it down. And so that is the difference between a normal virtual machine and what you would see under Fusion Compute. All right, so I thought I'd just show you that. So let me just suspend this virtual machine. Okay. And so that is really what we're trying to tell you based on the resource management and how Fusion Compute operates. Okay, so let me just close this now. Right. So again, quality of service with regards to the CPU, it's there to ensure that you have, enough resource allocation. So for instance, if you an IT administrator, and you need to set the limit of resources like your CPU, your memory, and your networks, and your IOPS, which is your input output um, processing capabilities, and that's available to the VM. You then obviously have to set that up, but you don't want non-critical applications or malicious users to take some of the resources, right? So you basically have to manage the quality of service. So again, that is the CPU quality of service. You have then optimal allocation to the resources, and also during the creation of those VMs, when you create a VM on Fusion Compute, your CPU quality of service is then specified based on the service that needs to be deployed. So it doesn't actually allocate the resources that's not needed. Based on what you need to be deployed, it allocates the CPU resources. And so it also gets determined by your VM's computing capabilities. It's not like you just set up a VM and say, oh, for instance, here we have this VM that I showed you now. So, if I now go in here and I say, oh no, but I want, okay, you see it's still on, right? So I need to switch it down. So let's just do that. Um, let's just resume and then switch it down. So for instance, if I now say shut down, right? So I'm going to shut down the VM, right? So now it's shutting down. And if I now want to do the following, so for instance, let's say I now want to, just waiting for this to shut down. I want to maybe increase the CPU memory. I can do that. But what if Windows 11 don't need that requirement, right? What if you can just get away with two CPUs and maybe just 4 gig RAM, right? Would that be sufficient? We don't know. And so again, the quality of service is depending on what's needed for that particular app. So in this case, during the creation of the VMs, your CPU quality of service is specified based on the services that needs to be deployed. And so it determines the VM computing capabilities. That ensures that the CPU quality of service of VMs and the minimum compute resources is allocated as a priority. So you basically just don't want to just unilaterally just allocate resources based on you want to have a fast operating system, but it's more about what's needed, and based on that, it determines what is the minimum resources that's needed. So again, this is just the VM resource management on the memory part. Let's say you overcommit your memory. You're saying memory, but you have overcommitted memory to one VM. So this is the feature that Fusion Compute also have. So you have a server that obviously allocates virtual memory, but now the server don't have that amount of memory physically available, right? And so what it does is it has something called memory ballooning. Now, if you remember your cars, if you buy a car, you normally have something called balloon payment, right? And so balloon payment is a future value. You get the car at a discount rate, on a rate, but you have a balloon payment that waits till you are done with your car. And as soon as you want to settle that car, you have to give that balloon money back to the car, not the manufacturer, the person where you bought the car from, right, or a company. And that's the balloon, so the balloon payment feature normally. So with memory ballooning, you basically borrowing future memory, in a way in where you basically now want to, if you can see here, you basically use memory and you keep it there, for future use in a way. So it's almost like a bubble that's available, and that's called, not the same context as with the car payment story, but you have this memory ballooning. You also have memory sharing and you have memory swapping. So those are the three things, right? So if we look at memory sharing and copy on write, this is now where the VM share the same physical resources, right? So you can see here in blue, it says all the resources. And also what it does is it only performs read-only operations on the memory, and then when it needs to write it, it then writes to the memory in read. So you can see here it writes to the memory in read, and then it allocates another space and modifies the mapping. So that is when you need to do read, write. So again, when you look at it, you have the two things that you need to look at. So memory sharing, you have multiple VMs that share the memory, on that page, but where you have to write, it writes to a different block, right? But you can see here, it has all this memory that's being shared. So for instance, let's say you have, I'm going to make an example. Let's say this is 6 gig, right? So you have two there, maybe two there, two there, right? So that's 2 gig, 2 gig, 2 gig per VM. And so again, what you will do then is you will then write whatever needed resources to that block, which is probably 6 gig in that case, memory that's available. So it will basically from that resources move to another block when you need to replicate on write, right? That's when you need to write on replication of those. So you don't replicate on the same memory that's being shared, you replicate on another address space in this sense. So this is memory sharing, copy and write. When you look at memory swapping, this is now where you have external storage that's involved now, right? So with external storage, everything is like your disk, your physical disk is then virtualized, right? So it's called memory swapping. So the memory data that's not currently in use is swapped and mapped to a disk. This is the term that you hear in Windows, which is called I think it's virtual disk memory or paging file. I think it's paging file if I'm not mistaken. But this is where you normally want to use the disk and use memory source from the disk. So if the VM needs more memory, it then takes from the disk space, and it's mapped out from the disk back to the memory block. So this is the memory swapping. So again, what we're doing there is we're taking the external storage, you virtualize that into memory for the VMs to use, and if that data is not used temporarily, that's not used temporarily, then it's stored to the external disk. But if it needs to be used, then it exchanges the data and reserve that for on the memory. And so the last thing is why I spoke about memory ballooning. And this is now where the system itself, reclaims unused memory, right? So we're ballooning memory, giving you memory, but it reclaims unused memory from a VM and allocates it to other VMs to use. So if you, for instance, this VM here is idling, all right? So it's idling and it's not being used, so it's gonna take from that VM and give memory to another VM that's maybe that needs to use from that resources that's available. And so again, it basically creates a memory bubble to release. So that bubble there is that ballooning that we have, which is future memory. So if that VM is not using that memory, it allocates to another VM that maybe needs it. And if it's done using it, it returns it back to that VM. So this is the whole memory. So for instance, this is maybe the car person who buys the car. So you get your money to use the car. And this is maybe your vendor or your reseller that basically, or let's make an example. This is VW. And they now, obviously gives you the car, but you need to buy the car. You didn't borrow, in most cases, money. And then when you're done using it or when you have to return the car, you give back that future value that it was borrowed to you. That's kind of the concept, but with regards to memory ballooning. So again, that is basically, but the server cannot exceed the physical memory on the server. So if it doesn't have enough, it's not obviously going to give you what you want for that VM. So it all depends on how it's being needed and allocated, and that obviously improves the memory usage on your servers. So these are concepts and things that Fusion Compute has. Now, I'm not saying other VMs don't have this or virtualization technologies have this. I don't know, but I'm just talking about Fusion Compute now, and how you can manage it as an IT administrator. So with the same memory resources and the VM density is then improved and the hardware memory procurement cost is reduced by 50%, because now you have this intelligence happening on your VMs with memory sharing, that you don't need to go buy more memory or RAM or anything like that. You basically just borrow from another VM, but you're doing it in a system dynamically way without needing to worry about physically changing things. So you can even borrow from the disk also as memory, which is called memory swapping. Okay, so now we're going to look at live migration. So this is the VM live migration, and so this is when you need to ask your users, or to migrate VM. So the user could be a website host person that runs this VM, and now you need to migrate that VM to another, to in a cluster from a physical server to another one without interrupting any services. And so again, the live migration allows you to, live migrate from one server to another without switching off the resources. As you saw earlier, I tried to do that with Windows 11 on my PC and I couldn't. And so that feature also allows you to do planned server maintenance, because you do this live migration without stopping any of the services. And your VM manager then gives you the quick recovery in case you need to share memory and data, so that before you do the live migration, everything stays the same, right? So there's no change in the VM as you move it across. And so this is basically this dynamic resource scheduling that we do have with regards to that. So here you can see this VM is there running, and it gets moved across to another server using Fusion Compute, which is your virtualization layer in this case. And so you can see you can do a live VM data move from one server to another server. This again could be a SAN disk drive that sits here outside, or it could be a NAS, depending on how this topology looks. And so again, this is where you would use the compression technology to double the VM live migration efficiency. The location of the VM disk, as you see here, remains unchanged, and only the mapping relationship changed, so it maps it to another server. And you have basically a short-term service interruption that is maybe tolerated, but the services must be recovered quickly. So let's say here's an example. This app could be a database, a lightweight database service, and maybe a desktop cloud service. So it could be MySQL server that's running, or any type of lightweight service that's running that you need to migrate. And so this is the live migration that you can use. When we look at VM high availability, so high availability, HCIA stands for high availability. So the VM high availability ensures a quick recovery of a VM. So when you're the administrator and you need to see that a VM is faulty, let's say the VM goes down, in this case it's faulty, you then basically then recreate the VM on another normal compute. So let's say this server here, in this case here, remember CNA stands for compute node agent. And so this compute node agent is now faulty, right? And what needs to happen is that you need to move the VM to a working one, which is maybe this one here. And so what happens is that, let's say fault gets detected, and that's probably one of the features, it has fault detection, and then it allows you to recover the VM, to a different host. And so again, you basically have the system sending heartbeat messages. So you have this high availability heartbeat messages that get sent all the time. So this is, for instance, this here is the messaging that's being sent the whole time, the heartbeat message. So it goes maybe from there, goes to there, and it basically just send these messages across, so that it actually is aware when something goes wrong, right? So it's like messages that get sent across the service, and that is obviously to help with the network, right? But you can see here also this VM here, in this case here, maybe fails, but it gets pushed over to another VM, to another server, and gets rebooted in the process. So it reboots, and then you have it running there. And for instance, even this one here, the same thing, maybe it's running and now just moved over. But again, it depends on how you would move it over and how you want to recover the VM. In this case, one is on, one is off. But again, what we're seeing is the VM is automatically restored to the new host when an unplanned power failure occurs on the host where the VM resides. So this VM is now down, but it's obviously, before it goes down, because of the heartbeat messages that it can send across these nodes, you basically can move the VM instantly across, knowing that the server is going to fail, right? And like I said, here's an example. This is a SAN storage, distributed storage. And previous one I said it's NAS, but same concept, right? So that is basically the VM high availability feature that Fusion Compute also have. You also have like a rule group. Now, rule group is how you basically allocate your VMs. So you want to make sure that they belong to a group, and so rule groups can be used to control the location and the relation between your VMs, because you just don't want to have a VM moving to another server without having maybe a connection to a group. And so that's normally when you have different type of applications, right? Like I said, you might want to have a standby and an active VM in most cases for let's say a web server. So if something goes down, you have a backup server that spins up. In most cases, or you want to scale up and scale down, or scale right and scale left, scale out, scale in, depending on. Okay, so you basically want to keep some VMs together. And so the rule group links VMs running on the same host. One VM can be added to keep only the VMs together in one rule group, and or you can make them mutually exclusive, as you see on this one here. So again, here you have a VM here. You have VM1 and VM2 on that one host, and you can basically aggregate the VMs, in a way in that they basically all work together. So in this case here, the virtual machines must run on the same host. As you can see here, there's the group created. And you can see here also, you can also have them mutually exclusive, where the virtual machines must run on different hosts. So depending on how you set it up, you either set it up like this, or you set it up like this, depending on, creating a host group, that it's two different hosts, but these VMs are all, working together. Or you have one host, and then you obviously put them all in a group. So it all depends on how you want to set it up, right? And in most cases, depending on the resources that's needed for that particular VM group, and you could also, do many other ways of how you would want to set it up. So again, what this allows you to do is you basically have a VM that runs either on different hosts. That basically ensures redundancy and reliability, in case, like I said, with mission critical services, we have, mutually exclusive, that you want to have a active and a standby kind of VM setup, like Oracle database. Yeah, so that could be a database one. You have an active database, and you have a one that's on standby. It could be running also together, like a master or slave, or you could have I think the word is actually maybe a server or agent, or you could just basically use it independently, right? One student says he can't hear anything. Can you guys still hear me? Unless there's something wrong with the student's microphone. Okay, you can hear me. All right. So Innocent, I think you must just rejoin, log out and rejoin again, or just check your mic permissions. All right. So again, the services must be distributed on different hosts, also if it needed. But if you have a VM to host, you basically have this here. We have the VM group that must run on the same host group. It should run on the same host as you set it up. So it's two hosts. And your VM should not run on a host group. If depending on how you set it up, more flexible VM group to host rules can be used, and you could also set it up differently. Again, what this allows you to do is have VMs to host, VMs to VMs, or keep them together, right? So it all depends on how you use the rule group. In most cases, it's not that you really need all of this rule groups, but if you have like an Oracle database and you want to have two VMs running the database, you would have a backup, right? So that's kind of how you have to set them up as a group. And you can do all of this in Fusion Compute. Dynamic resource scheduling. So again, this is basically a feature called DRS. So it stands for DRS. So you will hear this term also, dynamic resource sharing. So what it allows you to do is you use the intelligent algorithms that's available based on Fusion Compute to monitor the workload on host, right? And this obviously depends on the VM and how it handles power resources, and how it increases power consumption or reduces power consumption. But Fusion Compute then again monitors all these resources run together. So if you look at this here, you have an unbalanced load within a cluster. So here you have a VM, a VM, a VM running. You can see the CPU is being used on this host 80%, memory 80%. Here again, you have low resources. You have a CPU running at 30%, memory 30%. So what's going to happen is, because this is at 80%, it's going to move the VM across to that host, to that. And this is obviously is not the pool group or the cluster that you saw previously. This is now where we just want to have an unbalanced VM load running because it's unbalanced. So we move them to give the resources so at least it gets to 40% or even 50%, depending on what type of VM that's needed for the CPU and memory. So this is what really happens on Fusion Compute. It does this whole dynamic resource scheduling. So again, this one is 80%, so it's not going to use that side, but it's going to use this host because it has availability resources and it's unutilized, right? So that's kind of what you see here. You also have load balancing within the cluster. So again, what you see here now is, like I said, there's the 50% reads, right? Because we moved VM across, which means now all of this is at 50%, right? We moved the VM across here also, so that we have the balance part now of all our servers. And so this is basically what is called dynamic resource scheduling by moving the VM to a host that has not all the higher resources running. And that helps also the VM to cool down, sorry, the VM, the server to cool down because it's not running at 80% as it was. Remember, the more CPU power, the more electricity that gets generated, right? And so those are what you see here. So again, you have the adjustable threshold that it checks, scheduled scheduling, automatic migration, load balancing. So you can see here the balancing the load. It has intelligent algorithm that runs, so like an AI that detects how it needs to schedule based on resources that's needed, and there's also this flexible policy, as you can see, depending on how the VM runs. So that also helps with cooling. It helps with power usage, a lot, power management. It helps with a lot of things, and that's mainly why we have this part. That's part of Fusion Compute. You have dynamic power management, which is now the next one that I just spoke about now. So you have DPM, I think it stands for DPM, dynamic power management. And so again, this is basically where you have an automated power management that normally checks the resources, and it checks if the cluster has the sufficient power of the server load, and so when that's enabled, it basically automates your compute resources. So again, where you can see it's unutilized, or maybe in this case here the VM is moved, depending on if the resource is low again, it basically migrates it automatically. That's one part that it does. It also powers on idle host. If the host is idling, or when the load of the host cluster is heavy, it moves it across also. So if that host is offline, it actually automatically powers that host on in order to have this setup here where you now see the resources. So this host B could be on idle state or could be offline. There could not be any resources maybe. And what it will do is it will actually move the VMs across to that host if it's part of the cluster. And this is the dynamic power management. If the power of the host, is off, like in this case, you're switching it off, it obviously then also moves the memory across. Sorry, this the VMs across. So it does this whole dynamic power management depending on how many resources you have in your cluster. Right. So when we look at GPU, so GPU stands for graphic processing unit. So this is your graphics driver if you need to do any machine learning, AI, training, and many other things that you might need it for. So the GPU and GPU virtualization is a feature that's also available to the Fusion Compute. So pass-through means that the GPU basically have direct access. As you can see here, here's your normal host with pass-through. So you have your GPU driver on the VM connecting to your physical driver, which is the card, the graphics card. And when you have GPU virtualization now, you have the driver connecting to a virtual GPU still, and then only connecting to the hardware, right? So these are the two ways of showing you it, but I think with pass-through, it's better because you have direct access, to the hardware. So GPU pass-through is basically where a physical server can be directly attached to a specific VM to improve graphics and video processing capabilities, more for video processing systems like video recording systems and so forth. And then when you have GPU virtualization, which normally Intel does, because GPUs on that server can be virtualized into multiple virtual GPUs used by multiple VMs on that technology. But it has high performance and low cost. That's a good thing. And in this way, the GPUs are shared and user costs are lowered. So the two ways is a good way. The only thing is this is basically just on the host itself. We have the VM that connects, via GPU pass through, and you also have virtual GPUs that you can also get from a graphics card. So again, when you look at the requirements, you would say GPU pass-through is for high performance and graphics. And when you look at GPU virtualization, it's more for 3D graphics rendering, or acceleration, or 2D graphics processing. So it depends on the use case. And so just to show you on this VMware part, when I go to, I think I saw the settings here, settings. You can see here is there anything about GPUs here? I just see processor and memory display, right? So there is the supports DirectX, view modes. Doesn't give me much information here. But the VM obviously needs to be shut down. But again, you can see a shared graphics memory. It's trying to share the memory of the graphics card, right? And that's kind of what you see normally in Fusion Compute. It's that direct access, but this is a VM. Right, so you have either GPU pass-through, which is directly attached. How's this VM still running when I stopped it? Didn't I stop it earlier? Okay, let me just shut it down again. I'm not going to bother with this VM. It keeps on switching on its own. So let me just close. And just leave it for now. All right, so that's kind of the two ways of how you would see how the GPU is being used. So you have GPU pass-through and GPU virtualization. So here again, you can create as many virtual CPUs. So maybe you want 4 GPUs, or you maybe want 4 there. Then the GPU here might have 12. So you obviously taking from that 12 cores that's available there, right? So that's one way of how you would look at it. Okay. I know it's almost 10 o'clock. I'm going to take a 10 o'clock break because could say we're halfway. We're at slide 20, and there's a 70 slide, but it depends on how the slide spans out. All right, so when we look at storage virtualization, so we've covered now the GPU virtualization, we looked at CPU virtualization, what Fusion Compute can do. When you look at storage virtualization, it's where you abstract storage devices to data stores so that each VM can be stored as a group of files in a directory on a data store. And so what that means is that you're taking from that physical disk, you're creating data stores so that the VM can be stored in a group of files. Remember, it's kind of this file kind of storage part. And so the data store is a logical container that's similar to a file system. It hides the features of each storage device and provides a unified model to store VM files. So we'll just show you now quickly what that looks like. But again, the main thing here is that Fusion Compute basically uses storage virtualization, better to manage the resources and the version infrastructure to significantly improve the storage utilization rate and flexibility. So when we look at the following, we have the storage concepts and we have storage concepts in Fusion Compute. So we're just going to go through that quickly. Just be with me quickly. Right, so just getting back to the work now. So again, when we look at this, we have storage resources that we look at. And so again, you have the local disk on the host that can be used as storage resources. You also have dedicated storage devices such as your SAN storage, which I spoke about previously, the NAS storage. We now even look at Ocean Store, which is part of Huawei's storage service. Ocean Store Pacific, you have Ocean Store 6.x and Ocean Store Dorado. These are all, I would say they are NVMe SSD, if I'm not mistaken, um, drives that's used as storage. And so again, that is also part of dedicated storages, the services that you need. You have storage devices, and storage devices again is obviously where you use the LUNs, and this is where you have all that drives together. And remember, this is where we spoke about RAID, right? The different RAID methods using the LUNs, which is storage pools on a Huawei distributed block storage, which is also SSD, right? So that's the SSD block storage. And then you obviously have your shared NAS directories. Now, just to recap on the distributed block storage, if you remember, this VM is still running. I'm gonna have to kill this VM, but okay, don't do it now. If you recall, under storage technology basics, if I'm not mistaken, we had the talk on the block storage. So I'm just gonna go to that part now for you. Um, That's your LUN part that I spoke about now, but the block storage is this one, right? So this is the part where we have the data is not evenly stored in SSD. And so what happens is that Huawei uses this RAID 2.0, which is how, it's allocated in chunks, right? And that is that way of where we say we have this block utilization. Is it now this one here, block virtualization, right? And so that is what I was trying to speak about the Huawei distributed block storage, right? That part there. Okay, so you just need to refresh on the previous slide just to get context on where we're at now. So when we look at data store again, a data store, it's normally where Fusion Compute normally, runs storage units, and obviously it runs data resources into data stores, right? A data store is could be the LUNs altogether that sees it as a data store. And that's where you would store normally your files for your operating systems. And then also you have storage resources that can be converted into data stores. So your LUNs on your SAN devices, your SCSI storage devices, and your fiber channel SAN storage devices. Even your file systems on NAS devices, the ones I just showed you now, the storage pools on Huawei distributed block storage, your local disk, and your storage pool on eVol. So there's an eVol storage also that can also be used now. All of these can be converted to data stores. Okay, so Fusion Compute can use the resources, and then the pool then is the container that gets created in for that. So this is just showing you the storage features. Now, when we look at Fusion Compute, how the virtualization work on the storage side, you have your NAS here, you have your local storage, and you have a SAN here, right? These are your storage, can call it pools that you can use, right? And so basically, what it will do is those drives, those SAN devices, or any local storage disk that you see there, connect to the servers, right? But there's this generic block layer, right? Or call it driver layer, this block driver here, right? That basically creates an abstract view of the services. And so that basically creates this whole pathway to the file system, where you now obviously have the files that get stored from this. And with that, you have maybe image files that get stored on the file system, which obviously is seen as a EMU, like an emulator, and that then runs on the VM, right? That's the front end device that connects to that. So again, what you see here is basically the file systems are created on the storage devices, and then to create a file system, the host then formats that device, writes the metadata, and that gets stored, into the file system. And then the file system then basically makes that decisions and operations, and then the VM disks are stored in the file system. The disk driver then attach the disk to the VM. So the disk driver here, the driver layer, then attach that VMs, to that to the disk or the virtual disk in those cases, the emulator, and then that's how information gets sent across, right? So this is just showing you an idea or a way of how the whole architecture works with Fusion Compute, right? You have a file system, in this case NAS, that's separate, but again it connects to this, this block layer or driver layer, which then allows it to access the QEMU in most cases, or the image file. And this is basically how the connection works between the hardware and also the storage side, using the generic block driver layer, which is more for block storage, or the driver layer, which is more for any type of files that you need to store. So again, when we look at data store or Fusion Compute, we have virtualized storage, and this is where you take that physical disk, and you obviously create virtualized storage and break it down into virtualized storage. And you can also use non-virtualized storage again, and that is where you use the distributed block storage, right? The one I showed you previously, or evil, which is not virtualized. It's SSDs, but it's used as block storage, right? So it's not virtualized. And then you have the raw device mapping again, where you have your physical LUNs or your SAN storage that attach as a service to the VM disk, improving SAN storage performance. So again, that can be used in many ways. So you look at the disk in a way of how you would use it. You either use it as virtualized storage, where you create virtualized disk space from that. So virtualized storage in a way is, for instance, that VM is probably still running, so I'm just going to open this. So for instance, I take the disk here, and then you can basically add a device, and you can add a new disk, or you can add existing disk depending on what you need to do. And this is the virtualized disk storage that you're adding from a physical disk, because remember, I've got the physical drive, and so I'm just trying to take virtual storage from that NVMe hard disk, right? So that's one way of how you would do it. And then the other way is you take non-virtualized storage, which is taking the setup as you saw with the storage technology basics. Just open it again, where you take this setup here, which is again, just to get there, the setup here, you have SSDs, and they basically then gets broken down into chunks to evenly distribute data on as LUNs, to balance load. So this is the other part, but they are not virtualized, right? That is just your SSDs. And then lastly, you have your physical LUNs, which looks like, let's see, where's that slide now? That's a SCSI. It is the slide here. These are ways of how you use a physical disk, and you create these setup like this. That's RAID levels. I just want to get to the LUNs to show you what the LUNs look like. Better way of showing it to you. Let's see. That's another way also to show you the LUNs. And then you can even view it like this also, right? So you have different types of storages, right? So there's your disk arrays. It's like disk arrays. There's the NAS, right? So you can see the LUNs there, LUN 0, 1, 2, and that's basically how you allocate to block storage, right? And there's another way of showing it to you. Yeah, so you just need to go through this storage technology basics, just to get familiarize yourself with different types of storage, and how you would allocate storage. Okay, so looking at the storage model in Fusion Compute, when you add a data store to the local disk, right, you select the virtualization mode. So in this case here, it's either virtualized storage or it's non-virtualized storage. Oh yeah, I'm on holidays. I don't know why this thing pops up. So let me just snooze for the whole week. Okay. So again, when you look at this, you have virtual. Oh man, it's gone. Okay. You have virtual storage. And so with virtual storage, you have these raw disks that you can see here, you have a cow file, you have a raw file, VMDK, which is all hard disk, virtual disk, and these could be operating systems that you have a VHD, which is more, I think, Windows hypervisor, and you could have other files also, right? And these files is how you would store your operating system, right? So these are called VM disks, okay? And so these are virtualized storage. And if you have non-virtualized storage, you obviously have the physical disks that you would use, okay? And so when you look at this, when you add it to a data store, you can either choose virtualization mode or non-virtualization mode, depending on what you need. So they're not forcing you to just use virtual. You can use like the Huawei block storage 2.2, 2.0. And so when you add it to the SAN storage, right, you can select either raw mapping modes, or you can select the virtualization or the block storage, as I said, when you add it. And so here you have your file system. When those files gets added, you have a logical volume, which could be a shared directory, and then your VMs would be copied to that shared directory on the data store. And then these are the type of storage that the devices. So you either have a shared directory, you have the LUN, you have a physical local disk attached to the server, or you have a distributed block storage pool, or the e-volume storage pool, which is more the non-virtualized route. And then the storage resource could either be NAS, could be a SAN, could be the Huawei distributed block storage, as I mentioned earlier, which again is called Fusion Storage 6.0 now. Or you have your e-volume storage, which is attached on the server. Okay, so these are, yeah, the previous slides are on the, if you look in the group description, there's two links. There's a YouTube link for YouTube videos, and there's a Google Drive link where all the slides are in. So you go to Google Drive, you'll find recording videos there, and you'll find the folder called presentations, and you'll see all the presentation slides in there. All right, that's where you will find the previous slides. All right, so this is basically your model that you would use in Fusion Compute, right? When we look at data storage association, so this is now when you need to, map the relationship between storage resources and storage devices and the data stores. So your normal, relation is how you map it. So you have maybe a virtual disk, and so that virtual disk now gets mapped to a VM, or you would have a local disk that you would use. You could either use the LUN, or you could use a normal file system on a NAS storage. Depending on that, that's how you map it, as a data store to allocate to your VMs. Okay, so you have a local disk, which then obviously gets virtualized. So you do virtualization. You have a SAN device or IP SAN, and that gets also virtualized. Or you could use raw device mapping, which is obviously Huawei, what did you say? Huawei storage, block storage 6.0. You could also have NAS storage, and that stays NAS because those are how your devices are allocated. You could use block storage again, or you could use the e-volume, which is obviously non-virtualized, also similar to the block storage. So these two are a similar way of how you would use it if you don't want to virtualize any storage. When you look at the storage system now, which is called Virtual Image Management System, or VIMS, this is basically how it obviously creates this whole file system where you install, where you mount your VMs and so forth. So the virtual image management system is this cluster file system that stores all the formatted files accessible to be used. And again, this data stores basically supports different formats, and depending on how you need it, you basically would use this particular system to connect to IP SAN or FCSAN. And the key capabilities of this is to have high performance. So Fusion Compute is Huawei Cloud, like as well. Yes, it's like that. Yes, Fusion Compute. Now, Fusion Compute is behind the Huawei Cloud. So Fusion Compute is the virtualization platform, like VMware. What's it called? VMware Data Center. that was brought over, that was now actually bought by Broadcom. So that's Fusion Compute, but then you have Huawei Cloud. But when you do your HIP, you'll learn about OpenStack, which now again is the OpenStack version of Huawei Cloud, right? But Fusion Compute is more on a cloud computing basis, but it's more on a let's call it, you might want to run operating systems, right? For clients, right? Servers, and then you would use the Fusion Computer. But we'll get to Fusion Access, and you'll see how the two works hand in hand. When you have to compare Azure and Amazon Cloud, you can just say it's Huawei Cloud. But Huawei Cloud is built on, I think, OpenStack, if I'm not mistaken. Yeah, like a software as a service, correct. Yeah, that's what Fusion Compute is, yes. Software as a service. So again, that's basically where, if you look at, how it operates, you have these VMs, yes, and these are how you would allocate that resources. Um, when we look at, this virtual image system also, it's obviously the basis of how you have to virtualize your multiple storage services. If you need to do live migration, as we said previously, or you need to do the dynamic resource scheduler, or you need to check the availability for your storage devices. And that's the VIM's job to handle that. So it works hand in hand with Fusion Compute. So it's like let's call it an API that interacts between the two, or yeah, in most cases. Your VMs has a distributed lock, and so it's basically how this volume is mounted. So remember, this VIMs that you see there is mounted on your compute node agents at the same time. So it gets mounted as a volume, and then to allow your nodes to access the files on the VIMS volume. So VIMS volume is like a C directory, how everything gets mapped, right? It could be mapped from a SAN storage, could be mapped from a NAS storage, depending on how it's mapped. And that allows you to have data consistency when multiple nodes read and write the same file. So what we're trying to say here is that this could be, let's call it a Windows dot, what was that image file that I showed you earlier? Q cow, right? So it could be Windows dot Q cow. That's the file, right? That should be a dot there. So that's a file. And so that file, maybe this is a Windows here. Let's say this is, yeah, let's call this Windows. As a server, maybe it's a server, and that's a Windows server. And so again, you have two VMs that uses that same file, right? So they basically would use that file to, spin up, their server. That same VM they would use the same file to spin up that server. And that's what the VIMs does. It keeps that, that storage, it's like an integrated cluster storage pool. Okay. And that's why we're saying it greatly improves resource utilization, because you use one file, and that one file is shared across two different VMs. All right, I hope that makes sense. And that's kind of what we're saying here, is that to ensure data consistency, multiple nodes read and write the same file. The VIMs need to be implemented in a distributed file lock. So what we mean by that is, when you have a VM running, normally you can't use that same kind of file on a VM to copy and clone the VM, because it needs to be stopped first, because it has a lock on it, right? So the DLM, or lock manager, is part of that for implementing distributed file locks. Provides a lock service for the cluster concept, and that means that there's an invoker that uses the DLM lock manager to ensure synchronization between clusters. So the VIMS uses the distributed full lock symmetric lock mechanism, and then obviously what happens is that there's multiple resource managers in the VMs, and each master corresponds to only one lock resource. Um, and so that case basically is, if you become the master of a lock resource, you're either the first node, right? So the first CNA node are allowed to access the resource. And if multiple nodes access the resource at the same time, the node with the smaller VIMS node ID, so you get an ID allocated, is used as the master node. And then nodes access the resource at the same time, the node with the smaller VMs functions as the, nodes that access the resource at the same time. Okay. with smaller VIMs acts as a master node. So it starts from 0, 1, 2, 3, and it goes up. And that's kind of how the ID works. So if a node is faulty, the resources managed by that node will be released and elected as a master. So this is that way of sharing the resources, but making sure that everything is working fine. And so when we look at the VIMs, what it does, how it connects again, it has two types of heartbeats. It has this heartbeat to check whether the host can read and write shared storage, right, from that pool. And it has a network heartbeat to check whether the network communication between the host is normal. And so that is how the two heartbeats. So in a cluster file system, the CNA node mode mounted with a VIMS volume is not an independent individual. So you're not independent. You are sharing that resources. But in a cluster mode member, the CNA node ensures normal network communication with other nodes through the heartbeat. So in an individual part, you are just, you're not independent, but you are just using that model, right? That shared volume. And if you in a cluster node here, you use a network heartbeat to communicate. So that's what happens here with the heartbeats. They're trying to send heartbeats to see, are you still fine? Is your VIMS fine? As we're sharing the same resources. Okay, so that is basically how the heartbeat works. And so again, if I just want to just to show you this, I think I have. So, for instance, I'm just trying to see if I can just start up a new VM because this one is giving me problems. So, for instance, let's say I start a new VM. In most cases, here I say continue. I choose my operating system. For instance, I'm going to choose Windows. I don't know why it's saying Windows 11, but anyway, maybe I go Linux and I install any other Ubuntu version, and I go continue. It's going to ask to create a new virtual disk. Now, this could either in most cases with Fusion Compute, you would then use from that storage pool. So you could say, I don't want to create a new virtual, I will use existing disk. And then it will choose a virtual disk. Depending on the type of virtual disk, it could be either this one here, which is already, and I'll show you now what this looks like. So in most cases, I'm obviously using a VM, so it will look like this. You see that's an ISO image, and there's the virtual disk. I can't actually open it to show the package. Can I see it? Yeah, there we go. Can you see that that's a VDMK file, right? So this is the how the file, while the disk is being split into many pieces, right? But you could use it as one disk. Obviously, when I installed it, I should have said one disk. But obviously, by default, VMware likes to install small disks, right? So these all add up. All of these add up to, let's say, there. That's a VDMK. Yeah, that is I just info. All of this adds up to the operating system, right? And that's a type of file disk that you can use on any other type of VMware machine. But now, when you look at this and you look at you could use an existing one on the storage pool. And that's essentially what I'm trying to tell you. Just go back with regards to how does this heartbeats work. This one is still giving me problems. And so it uses from that resources there. And so again, just to go back to what you saw earlier, this is the VMDK that I just showed you now, the copy of that operating system. And so that file, one disk, I should have had one disk, but I have many disks, VM disks, images. But you could have one disk that could be an operating system. And that is what we're saying that's being said. So you have like almost like a master OS disk there that can be used, as VMs, as multi VMs. I hope that gets a better picture now to show you basically where I started with a Windows cal file, which is not a VMDK disk, but that's basically what I'm saying with regards to that. Okay, so when we look at e-volume storage again, e-volume storage is where you have, now a virtual disk, as you can see here, versus raw device mapping, which remember we said is from your disk, taking raw device mapping, and you have the e-volume disk. So again, here you have three scenarios, right? You have VM1, you have VM2, and VM3. And so with VM1, you have a virtual disk and you have the VIMs connecting to that LUN that gets actually access to the storage pool, which is this LUN, right? Um, and that's basically creating that whole virtualization of the virtual disk of that VM. And so it gets stored on this LUN, right? The virtual disk space gets stored on the LUN. And then you have e-volume, or let's say e-volume, which is the e-volume disk again here, which normally is, they say originally it's an advanced SAN storage, but it uses also a storage array. But remember, eVol uses physical disk resources. So it has this iSCSI or fiber channel kind of connection, and that allows it to, it doesn't use VIMs for storage. Remember, it doesn't use virtualization. So it uses those resources that's available, and it stores the VMs, or it retrieves the VMs from that disk, right? And so that's basically why you would use this for the likes of Ocean Store, which is physical disk. There's no virtualization involved with the eVolume disk because it's like block storage. And then obviously you still have Fusion Compute that works together with it. Raw device mapping again is also using raw disk as the same concept. So basically, if you have a high input output storage or low latency, automatic service provision, high performance of virtual services, such as a cluster file system and video and image processing and computing storage, that's basically a scenario where we'd use this kind of setup, right? You either use the virtual disk if you're just going to use virtual machines, but let's say you want to have high performance, low latency, you would go for instance, with the iSCSI because you attach directly to the storage, or you would go for iSCSI or fiber channel. So this is basically how we look at e-volume storage. It gives you different operations, such as VM disk provisioning, but it doesn't use VIMs, the virtualization part. All right, Karabo, the class I recorded, just go on WhatsApp under the group description, and then you'll see all the links there. Right. And so that is a way of just giving you the difference between virtualization as well as the raw device mapping. In many cases, it depends on how you use it. Right. So with regards to different disk types, if you look at Fusion Compute disk parameters, you have a normal disk type, which again could be either non-shared, it's only used by one VM. That's obviously when you have this particular VM, the K, which you saw earlier, or you have a C cow, oh, what's it cow? I can't get to the name now, but anyway, those are the disk files, right? So you could either use that and you use it for one VM only, or you share it with multiple VMs and then you need to have a ID, right? So the lowest ID gets preferences. So let's say it's ID 0 or and then you have an ID 1, then that one gets preference because of the type of VM as the master. You either have a configuration mode, which is obviously how you provision your disks. So the configuration mode is how you allocate the disk space. Okay, so normally when you have common, you allocate the disk based on the disk capacity, and so everything gets zeroed out. So what it means is that if I wanted to, for instance, just sorry, that's that VM again. So if I need to do maybe just take a disk, or not this one. Let me just do a new, and I now want to create a new VM. I continue, go next. I need to create a new virtual disk. So when I go continue here, it automatically, well, I don't know if it actually created it, but let me just customize. It wants me to create a VM, right? And so there's this option where you have to say share this virtual machine with other users on the Mac. This is the shared part that has a shared cluster, which means that you then have this VM available to another VM. But in this case, this is not the same case as the concept. This is a virtual machine you're sharing, not a disk, right? So this is not going to work. But again, you could, in this case, this is just telling me that I can only use this type of file image, right? But again, if you needed to, thin provision it. So again, what you do with that is you kind of have this happening on servers, not on a local thing like I did it now. You have common a disk capacity as you zero out the disk. I actually don't have access to a server now to show you this part. Or you have thin provisioning, where you take only part of that disk. So let's say you want to use 20 gigabyte, right, of disk space, right? So the VM needs maybe 20 gigabyte, right? The VM needs 20 gigabyte, and you just basically install Windows now. And so if you do thin provisioning, only the resource that's needed. So let's say the VM only needs 8 gig to run Windows, right? Then it's just going to use the 8 gig from that whatever is allocated. So you could have set it up in the beginning and say, okay, the VM must have 20 gig disk space. Only 8 gig will be used, so that's a thin provisioning. If you do common, you allocate all the space. You allocate the whole 20 gig to that VM, right? So only the part of the system, okay, part of the configured capacity for the first time is being used. So in this case, the 8 gig, and then allocates the disk capacity step by step based on the usage until the allocated capacity reaches the configured disk capacity of, let's say, 20 gig in this case. Okay, so you would have 8 gig only thin provision instead of the 20 gig until you reach the 20 gig, you reach the full disk capacity. And when you look at thick provisioning lazy 0, this now allocates the space to the disk based on the disk capacity, which in this case is 20 gig. And so when the disk is created, the little space is marked and all space is allocated for the first time. So with thick provisioning lazy 0, everything is allocated immediately based on the requirements of that VM. Right. So again, common, it depends on the capacity that's available. And obviously, depending on that, that's the common way of how you would do a virtualization, or how Fusion Compute virtualizes disks. When we look at this mode, you have the three different modes. You have dependent. And this is now obviously when you have a disk that you add a snapshot. You create like a snapshot in memory when you write information to that disk. Right, you install Windows, then it creates a snapshot. There's a like an independent snapshot that's created, and it saves everything permanently. You either have an independent and persistent, meaning that if the disk changes, so you write files to that Windows operating system, you install software, everything gets written immediately and it's permanently on that VM disk, right? And so there's no snapshots there that if you need to restore something, you go back to a snapshot mode and you do a previous installation, maybe like system restore. That's not there because everything is persistently stored to that disk. So you can't undo anything. So there's no snapshot. Or you could have independent and non-persistent. That means that the disk changes are discarded if that VM gets stopped or restored using a snapshot. So those are the three different disk modes. One, dependent, which is included in the snapshot, and everything is written immediately and permanently. And then you have independent and persistent, and independent and non-persistent. All right. So that is that. Now, before I get to Delta this, let's take a break. I've been talking for probably 85 minutes. I'm just checking the time now. Let's take a break till 11 o'clock. We start at 11 again, and then we'll continue from Delta disk. In the meantime, I'm just going to stop the recording so we have this part covered. And let me just see. Yeah, I'll just stop the recording and then we can start again. Let's see if I'm stopping it. Okay, there we go. And we can start again at 11 o'clock. So we'll give a 30-minute break, and then I'll just convene.